This is 6.3 Exponential Functions, Part 2, which is graphing. To graph an exponential function, make a table of values, and then you will plot and connect those points. So there's a couple things to know. If we have our exponential function, and we have a minus h, whatever that h value is going to shift it horizontally. If you have a minus 2, that will shift it to the right 2. If you have a minus negative 2 or a plus 2, that will go to the left. If you have a k value, so plus some number, that will shift it vertically. So we're going to be graphing these two functions, and then we'll look at them side by side to see how they change. So first I'm going to make a table of values. So I chose my x's. I choose ones that are around 0. Plug this x into your function, and then you get y values. And we can see that they start growing at larger rates. So then I'm going to graph it, and you have when x is negative 2, y is 1, x is negative 1, y is 2, 0, 4, 1, 8, and 2, 16, which is way up here, but I didn't want to draw in the middle of my table. Now the domain is talking about whatever x can be. So if we continue this on, x will eventually reach all real numbers. It might take a long time. The y will be super great, but it will get there. Now the range, if we continue this on, it's going to get closer and closer to 0, but it will not ever actually be 0. So the range is all y's greater than 0. Now for the second function, again, if I make a table of values and I plug it in, it's a little bit messier work, so I don't have all my work shown. But we have when x is negative 2, y is 17 over 8. That is 2.1 and a little bit. So it's just above 2. When x is negative 1, we get 2 and a quarter. When x is 0, y is 2.5. X is 1, y is 3, x is 2, y is 4. So we can see here. The domain, again, is all real numbers, and the range is y's greater than 2. So if I were to put these on the same coordinate plane, I could see that it's the same one. They're going to have the same shapes, but this one is shifted up 2 and to the right 3. So this point, if I shift it to the left 3, 1, 2, 3, and down 2, 1, 2, it's going to be at 2. And that's what this point is. So I had a minus 3 and a plus 2. I shifted it to the right 3, up 2. Now let's try one more. For y equals 3 times 2, x plus 1, again, I chose my x values, and you plug those into the function, and you get your y values here. Remember, a negative exponent turns it into, it will end up being like a fraction. So then when I plot those, I have negative 2, 1.5, negative 1, 3, 0, 6, 1, 12, and 2, 24. So this one is much steeper, much faster. So make your table of values, get your y's, plot, and connect them. The domain is still all real numbers, and the range is y greater than 0. The range is affected when it is shifted up or down. So that is the plus k here. This h that we have is not really going to affect the domain when it has this shape. For other shapes, it's possible that it would change it.